For this video, this lab is called Mass versus Weight Lab. You should be on page 23 in your notebook. Right now it's a blank page, but I'm getting ready to show you a chart that I want you to put in there. Because in this lab, so on page 25, you're going to see a chart. So I can get it on here pretty good. I want you to copy in this chart that I have here. What we did is we wanted to figure out what the difference between mass and weight was, so we did a warm-up on that, which we knew mass was just the matter that something is made of, all the atoms, molecules that an object is made out of. And we figured out, well, that doesn't change anywhere because the number of atoms and stuff that are in your body and in the object doesn't change whether you're in outer space or on Earth, so that should never change. But weight is that force that acts upon you, gravity. So your weight would change as you moved from, say, Earth to the moon or outer space because you don't have the same gravity acting upon you. So on Earth we know, and we figured out in the last lab, that gravity accelerates at 9.8 meters per second squared. And so in this lab we're just knowing that there's this constant gravity pulling us on, but as weight continues to increase, or I'm sorry, mass is what I should have said, we're going to see hopefully a pattern here with what is going to happen to the force. Obviously, we're going to start with one marble. So we started with the spring scale. So I'm going to show you the spring scale. So hopefully you got that in your notebook. But then I had a spring scale. And it looks like this. You hold it up, so it's kind of the force of gravity is pulling down. And you can see kind of the spring down there, and inside there's a spring. And at the bottom, you're going to hook something on there. And on one side, you have newtons. That is the force. So that's the weight. Right now it's at 0. You can see the top disc there. And then on the other side is grams. That is the mass of the object. So we put a marble in a baggie, and I'm going to hang that. So we hung that at the bottom. And then we took a measurement of, see, the marble's in this bag here. I don't know if you can see it or not. There it is. And we hung it up without it touching the ground. And we saw that the newtons were about 0.2, and that made the gram, the mass, about 20. So then we added that to the chart. So on our chart, well, we predicted first. Most people predicted like 10 grams, but we really got 20. And then for the newtons, most people said like they thought it would go all the way to 1, but it was really only 0.2. So then we predicted again, and so this time, since we saw we really had 20, most people guessed, well, if I'm at another marble, it's probably going to double, so it's going to go 40. And the actual weight, the newtons, they guessed since, well, this is double, then a lot of people would just guess, well, then this number that we had before is probably going to double now and get 0.4. So then we added a second marble to our bag, and we hooked it back on again. And then we took a measurement again with this spring scale, and you can kind of see there it went up to 40 grams mass and about 0.4 newtons. So it did what we thought it would. So we added that to our chart. 40 and 0.4. So then we thought, well, if we had another one, it seems like it's going up by 20 every time. So most people said, I think this is going to be 60. And this will probably be 0.6. And then we added a third marble and did the same thing again. Now we have 3 marbles in the bag. And here's our spring scale. Again, like I said, we have 3 marbles in the bag now, so I'll show you that. 3 marbles. And over here, here's our newtons. And most people said, now sometimes we can kind of see here is about 0.6 newtons. And if you turn around to grams, there we go. You get about 60 because each line is 10. So we got that right on our chart. Most people just added 60 and 0.6. So again, we predict again. We thought this would be 80 because we're adding 20 each time because each marble weighs 20 times 4 marbles. And then it seems like that the Newton force is going up by 0.2 every time. And then we added our last marble, our 4th marble. And again, hung it up. And you can see 4 marbles, except my hook is not right, so let me check it. And when we measured it, we had what we thought was about 0.8. This looks like about 0.8 newtons. Here's the newtons. The the weight was about 0.8 newtons, but then the grams was about 80 grams. Okay? And then we just added that to our chart, and then we just kind of discussed that pattern, 20, 40, 60, 80. So each marble had 20 mass. It has about 20 grams of atoms in it. So even if I took these marbles up on the moon, you would see that same chart of the actual mass. But if I took the marble up to the moon, would I see that same scale on the other side of newtons? Well, no, because it would have different gravity. There'd be a different scale there. But you can see the force goes up as you add mass. So gravity is acting, if you have more mass, there's more gravity acting on that object. So mass is important.